guys, it's Bob from Lighthouse Aerial Imaging. I just wanted to let you know of a really cool new feature that we've just introduced on our website here. One of the things that we do with our drones is 3D modeling, large-scale 3D modeling of great big pieces of property. And how is this handy to you? How is this handy to your business? What we do is we do large ortho photos and photogrammetry of earthworks projects, excavation, aggregates like mining and stockpiles, and construction projects as well. And for those of you in those fields that have not used drones for this, I think you'll find this really interesting, and especially some of the things that we can offer you. So basically what we do is we come out and do a 3D image of your project. And how we do that is we bring out the drone, one of our fleet of drones here, and we take all sorts of pictures. We do a pattern of your area, and we take all sorts of pictures back and forth, sometimes several hundred pictures. I have a project coming up where I'm going to be doing over 900 pictures. And then we upload all those into some pretty advanced software. And then what happens is we send you a link. And when you click on that link, what you'll get is this. You will get the results of the stitching of all those pictures together. Now, this is a fairly severe erosion problem in Ontario along Lake Erie, near Port Burwell. So what we have here is this is all of those pictures stitched together, and you'll see as we zoom in, the resolution actually gets better and better and better up to a certain point. Okay, so you can look down inside this little canyon here, and you can actually see where the water is coming from along the sides. There's a water table underneath the surface. Now, what you see in the background is the Google Earth image. One of the cool things about this particular program is down here, this slider. If you slide this back, it fades away. So now what we have here is the latest Google Earth image. This is from 2018. So this overlays the picture right on the Google Earth image, and you can see the difference between 2018 and April of 2021. Fairly significant. Now you can select different maps. You can select the Esri satellite map, which is even older, and see the difference here. Okay, but there's also other maps you can do. You can do just a street map as well. Not really as effective as the Google Earth map. So one of the other things that this does, once these pictures are taken, you can sit here at your desk, and now you can do a bunch of measurements. And you can do measurements really quick and easy with this software. You go over here to the measurement thing, and it will do all sorts of measurements. If you just want to do distances, you start measurements by picking a point. Pick any point, and there's your first. And then you can slide around and you can pick another point. So if you want to know how far it is from one side to the other, there it is over here in meters, 216.45 meters. And it also gives you the latitude and longitude of the points that you picked. The other thing that this will give you is, you'll notice over here, there's a wind farm. This is the Erie Farms wind project. Every once in a while, they must get a little bit nervous when they see this. So let's go from create a measurement from, say, the tip of this one right to the base of the wind turbine, and that's 350 meters away. Now, if you were to fade this out, move this spot over, probably have to create a new measurement. So let's create a new measurement. From there to there, that was 395 meters. So they have lost 45 meters since 2018. So that's something that you can use this to kind of plot the future, I guess, if you will. The other thing is that this does a really good job of doing area and volume. Now, this obviously is a depression in the earth. This also works the same as if you have a mound or a stockpile. It works exactly the same way, and I'll explain that in the middle how it does it. But first, the process is really simple. So let's say we want to fill in this part of this arm. We want to try and fill this in and see if we can, get some of our usable ground back, which by the way won't work. But if we thought we wanted to do that, how much dirt would it take to fill this? So let's just get an idea of the volume. So all you simply do is start with creating a new measurement, and let's just say we're going to do this part here. So all you do is just trace it out. I'll do it really quick. The more points you pick, the more accurate it will be. So we'll just do this real quick here, real fast, and then back along here, and then finish the measurement. So right away, it already knows that the area inside this boundary is 2,000 square meters. The perimeter of that boundary is 203 meters, and the volume within that boundary is 11,422 cubic meters. Now, you can export this information into a JSON file for down the road. And why would you do that? You can bring that back. So if we come along and we do another flight and do another orthomosaic, say in another year when all these areas are bigger, you can bring this area that you plotted and put it right back on there again. And you can put it right back onto a new image. All of the pictures are geo-referenced. They all have pretty accurate GPS coordinates. So overlaying this image onto a new ortho photo, really easy and very accurate. So how does this looks like a 2D image, and it is. How does it know the volume? Well, it knows the volume because it also does contours. This button here will show us contours. So I'm going to do a 2 meter, because I know that this is around 20 meters deep. I'm just going to do 2 meter intervals. And it's going to generate the contours for this area. Give it a second. So there's the contours for this whole area. So if you click on one of the lines, it shows you that's 206 meters above sea level. Next one down is 202 meters. The bottom part of this part of the canyon is 196 meters above sea level, and way down here near the water is 184 meters above sea level. So the way that it gets the area calculation in this light green area is it takes the area at each of the contour levels and adds them up, and that's how it knows the volume. So these are trees. Over here's a pretty tall tree, so that's 220 meters. So that's why it works in both directions, whether it's an indentation in the land or whether it's a stockpile or a mound or a mountain. It can figure it out in either direction. The other things that it does, let me turn off the contours here. There's digital surface models and digital terrain model. Given in heat map settings. The plant health button here is something I don't use. There is a plant health thing where it will figure out the health of your plants, but that's normally done with multispectral cameras, and this was not taken with a multispectral camera, and I don't have a multispectral camera. However, if you are interested in plant health photography, this software will actually work for that as well. So that's the ortho photos in a nutshell, and right away this can be a great value to anybody that has earth type projects that they need to track, they need to keep track of. If you have like I say, a quarry or a mine, and you've got stockpiles and you want to know what the volume is of a stockpile, this can be done really easily, really easy. Now, the other cool thing about this, and here's where the power of this software is, the three-dimensional photo, or the three-dimensional representation. So here is the same thing in 3 dimensions, and we can spin it around. We can look at it this way from above and actually see now this is a 3D point cloud. If you look really closely, what happens is the software takes all of the pictures and stitches them together. Every place that there's a common point between 3 or more pictures, it actually plots the point. So that's what each one of these dots are, is plotting the point. And then if you go over here to where it says textured models, and check that, what it does, it takes a segment of each of those pictures and wraps the picture around those points. And there we are. So you get a really accurate 3D view of this particular erosion situation here. So, and you can scroll around, you can zoom in and out. So that's how now, don't worry about it. This is not a waterfall. This isn't Lake Erie going off the edge of the earth. What happens is when the drone only comes out this far to take a picture of it, and then the water, it looks like it's farther away, and it's also really hard to plot water. So the software doesn't even try doing it. That's why it looks like it's doing that. So here's the actual shows where all of the cameras were, where every picture was taken. You can see how this was done and where every picture was taken. In my version of the software, when you click on one of the points, it shows the actual picture that camera took at the time. The link that you get won't see this. You'll just get nothing there. But that's what every picture looks like. It just goes through and takes all these pictures and stitches them together. So let's turn those off. Now, here's some of the other tools that are available on this, which are handy as well for anybody doing any sort of an earth project, especially landscaping and aggregate management. Besides doing linear measurements, which this does a great job of, you pick a point and drag over to another point, and there's your measurement. So across here to here is 68.29 meters. The nice thing about it, it does height measurement. So if we go to the deepest part of this little canyon here, and then go over to an edge, you'll notice that it creates a right angle triangle here and measures. So it does an extension out here, and then it goes 90 degrees up to the next surface. And from there, it's 19.4 meters high. You can move this around over to the other side. You can move it, wherever you want. You can move it halfway up the embankment. So let's leave that one there, and then let's go over here farther and do another one. So from there to the edge of the bank is 11.6, and let's do the same thing over here. Gotta select it again. Oops. And so once those are attached, they stay attached in 3 dimensions. So you can actually see how the measurements were made, and all the labels stay on there unless you want to delete them, and you can delete them later. And then again, like I say, you can do your linear measurements if you want to measure the distance from there to the edge of the bank, 313 meters. So there's some pretty neat measurements that you can do right at your desktop, and you figure out what you think is the most important thing to measure. It will calculate angles. These are some things that I don't use. I don't particularly have a use for them right now, but it will measure angles from north. If you plot a circle on there, it'll give you all the circle measurements. Now, contours. This will give you the cross section of a contour. So let's say we want to see the cross section from here over to here. Now, what it does is it plots right through all the points all the way across. Now, it doesn't look very interesting here, but if we go down to here, now we can see the two-dimensional profile all the way across. And it's showing, so it's showing the coordinates. These are UTM coordinates, so northing and easting, and then the elevation in meters. So the UTM coordinates in meters and the elevation in meters above sea level. And you pick a spot all the way along here, and you can get the measurements and coordinates of the cross section. So now you can pick a spot anywhere on here and just put a dot. Now you'll notice up here, again, this is the same thing. These are your UTM coordinates and your elevation. If you scroll down over here, we picked a height. So anything that's on that you've plotted on the map will show up on here, and anything you select here, you'll get more information down here. So any place where we did a measurement, if you click profile for measure, it will plot a profile line on there for you as well, so you can see exactly where the line goes across. Now the one thing in the point cloud is wherever you stick a point for a measurement will actually go to the dot. It'll go to the point of the point cloud and not a spot on a picture, if you will. So you'll notice if we move this somewhere farther into the gorge and then look at it sideways here, you'll see that now the distance is below ground, and it's the straight line below ground now. So that's so it plots linear distance through the earth, if you will. So the point cloud doesn't really care if you go through it or not. So we'll put that back up there onto this spot. So that's some of the really good and useful measurements. Again, it's up to your business as far as how good and useful they are, but this is some of the power of 3D modeling from drones. So we can get rid of all of this stuff, 1x, and it's gone. The other thing is all of this information can be downloaded, so that you can use it in various other GIS software that you have. So if you're doing surveys, then this integrates quite nicely, all of this. So there's some of the cool things you can do. Now this section down here, I don't use this as a volume measurement. I don't use it because it's not as accurate, because it looks for more things to what I'm looking for. This will do volume of a cube, so it'll plot a cube there, but what it's going to do is actually give you the volume of that whole cube. Volume measurements are best done in the 2D mode here, as we did earlier, because it is really accurate, because it is based on the digital terrain contours. The other thing that I forgot to mention as far as downloading, on the ortho photo, if you click anywhere on the ortho photo, you'll notice these particular different profiles and model types are available to download. So you can download, when you click all assets, it will download everything into a zip file. Your ortho photos are in GeoTIFF format, terrain models in GeoTIFF format, surface models, same thing. Point clouds are in LAZ, LAZ format. The textured model, I believe, is also that as well. The camera parameters, which you really don't need. And then there's a quality report, which is more for me than anything. But the quality report shows the date that this was done, how long it actually took to process this whole thing again, which you really don't care about. But there's the area in a square kilometer of the area that was covered. There's all there's actually the route that the drone took and the number of pictures that it took. it processed 325 out of 330 shots. That means it didn't use 5 of the pictures for whatever reason. These are just kind of previews of what the software is showing. So there's the digital surface model, the digital terrain model. So this is areas where there was 5 or more pictures common at any given point. In green and the red were areas where there was only common points in more than 2 pictures. There's our GPS error, which is really low. Areas where there was more features. If you one click will download everything all at once. So all of this is available, like I say, the GeoTIFF files and everything. Handy, you can put them right into your GIS mapping software as well. So just going back to the 3D. So this is everything you can do. When I send you a link, this is exactly what you'll get. So it's your project. You can manipulate it any way you want. You can't change anything on here, so you don't have to worry about screwing anything up. But whatever you do, you can download. So you can download things in the DXF files and JSON files as well. Oh yeah, the other thing is annotations. So if you want to label something, so over here, actually there was a drain somewhere. Where did I see it? I'm going to bring the textured model back. So you can put in a title. So if you wanted, if you wanted to notice a particular point, and then you want to change that, come over here to annotation title, and you can put in deepest portion if you want, and that changes to that. And then you can actually put in a more of a description. So when you hover over it, so if you want to put in more of a description, deepest runoff south flow. Oops, I can't spell. 2 F's in runoff now, just in case you were wondering. So when if you go over top of that, there's your annotation. So you can save this in a few different ways. You can do a screen capture if you want. You can set that up. Get rid of that. So you can set the picture up any way you like. Wherever you put an annotation, it stays attached wherever you put it. Okay, so from here you can do a screen capture if you want and save it, or like I say, you can download the scenes. So when you leave it just in the point cloud, one of the things you can do is you can turn it sideways, and now you can see, so you can see that side of it. But if you turn it upside down and kind of flatten it out here, you can actually see, so you can see how the depth changes of this particular feature. So in this particular case, erosion. So you can get a good idea of the angle going down to the water here. So that is just another way to give you a better visualization. Sometimes you just take an aerial picture. This is what you see. Doesn't really show you much. It's not until you start looking at the 3D aspect of it that it's really handy. And especially when you look at it that way, it gives you kind of a really good indication of the slope and how it's running off there. So this doesn't look very big on the pictures. When you measure it out, it's pretty good. But then when you look at it compared to a Google Earth image, that it overlaps, like there's a little house and a barn there. And this is just going to keep on growing with time. So this is what 3D imaging from drone photography can do for your business. If there's anything that we can do to help your business out, by all means, back on the website, you can contact us through the website, info@lighthouseaerialimaging.com, or give me a call at that phone number and ask for Bob. Thank you very much.